So I'm going to copy just like the headlines. But you need 1, 2, 3, 4, 5, 6, 7, 8 rows going across. And then 4 columns. Across the top. F prime of double prime. I have more paper. If you like messed one up. That might need.
Yeah, I do. No, I'm just kidding. I can use the back. Look at that.
Big brain.
Oh.
What do you want? Other one? There's more right here. Wait.
Zach, fix it.
So every question you're asked is about f, right? Like even if I show you an f prime graph, I'm asking you about f. F double prime graph, I'm asking you about f. So over here on the left hand side is if f is increasing, decreasing, relative max, relative main, effective up, effective up, whatever. And then what would f look like? What would f prime look like? What would f double prime look like? Do you want a minute to like try to do this on your own, or should we do it together, or what's best for you guys? Fun. How many would like a chance to do it on your own first? Let's do. So I'll give you some time to try it. If you don't want to try it on your own, just like work on the packet for 5 minutes, or wait, or do it in pencil, or do it on a separate sheet, and then you have like a master copy that's not like if you make errors. So let's say that in like 5 minutes, maybe 10, I'll go through and do it and explain each box. You want to try it before that? By all means, I think it's a good idea, but if you don't want to, I get it. What else want the straight edge? That's it. I shouldn't have sailed. You stopped already. What's that? Yeah, I watched the game.
Did you? All of it?
Then I couldn't get to sleep. I was like kind of excited at the end.
Did you watch all of it?
Oh, yeah.
That's about it.
I don't know, but just I wanted George to be punished.
I would have watched it. Better.
But yeah, I regret watching it.
I wish Cincinnati would have won.
Oscar here? He's been rolling like 10 minutes late.
Oh, you know how to do that.
Like 10 o'clock. How late is it?
Whatever column it is.
No, this is his first hour.
Look. Like whatever column it is. 115 or whatever. Yeah, whatever column it is. That's what graph it is.
For where? Not every time for sports. What do you shoot?
Well, that's for the second. Just for the first. Then you just gotta get that. Yeah, well, I was just
Remember, like more time on the graphing thing? Alright, let's go through it then. Are you sure? Okay, so this is like if f is increasing, what's true about f? So this is just like you're looking at the actual graph you're being asked about. Like I'm asking you about f, I'm looking at it. So increasing just means positive slope, or it's going like that, or like that, or like that. Those are basically your different scenarios. F would be going up. If f is increasing, y values are getting bigger. Positive slope. Decreasing the opposite, right? Negative slope. Then it could be like curving down, curving up, or it could be flat. Not flat, but straight. I might as well say it. Just cuss me out. It is a straight line. This is a curse storm right there. Relative max. You have like going up and then the top of the hill and then going down. So we're switching from increasing to decreasing. Or we're switching from a positive slope to a negative slope. Relative is the opposite, right? So down to up. So you go deep to ink. Or negative slope to a positive slope. So like right there, realize that increasing and positive slope mean the same thing. So what does the word slope mean? What does the word slope make you think of? Yeah, in calculus, what does it make you think of? Derivative, right? Isn't the slope the derivative? I didn't ask that question very well, but that makes sense, right? Slope is the derivative. So if you say the word increasing, since it means positive slope, it means positive derivative. So if you say increasing, you've essentially taken a derivative. Something is increasing, it's getting bigger, which means it has a positive slope, which means it has a positive derivative. If you say increasing or decreasing, you're talking about the rate of change, whether it's getting bigger means you're talking about the derivative. So like increasing is a positive slope, that's a positive derivative. So a lot of people keep messing up the word positive and the word increasing, and then negative and decreasing. Just trying to help with that. Concave up is increasing slope. Curving upwards. It's going to look like one of those two things. You got the U. You got the U for up. And then concave down is the opposite. So decreasing slope. So you get that, or it's like the N. And then a point of inflection is where it switches from one to the other. So from up, down, or from down to up, it's a change in concave. So that's if you're given the graph of F. Usually you're given F prime. I'd say 80% F prime, maybe 70% F prime, 20% F double prime, and like 10% F. Other questions on F? Why does this make sense? I don't understand this part. Is that good on F?
Yes.
Alright, so F prime. If F is increasing, so this is the derivative, right? If the original graph is increasing, what's true about the derivative? Positive. F prime is positive. Graphically, what does that look like? Above the axis. Good. I don't really want to draw that. It's just like I put a line with like some squiggles above the axis. That doesn't make any sense, right? Above axis is fine. Yeah. It does not define the shape. It just means like it's up here doing something. So F double prime or F prime decreasing. If F prime is negative, F is decreasing, or it's below the axis. Yeah.
So when the slope is positive,
Slope of what?
when the slope of F prime is positive.
Now you have the second derivative. Because if you take the slope of F prime, you're taking the derivative of F prime. I feel like I'm interrupting your question by correcting you, though. Which I don't know if it's helping or hurting.
I'm just trying to picture it in my head. I'm trying to figure out what is positive.
So if this was your F prime graph, F prime is positive. There's negative.
Okay.
Just above the axis.
Alright.
So the F would be increasing. F would be increasing.
Okay. No, we're not talking about that.
If I did that, if I take the slope of this graph, now what am I getting to? Second derivative, which tells me about. Okay. Are you okay yet?
Yeah.
Any other questions yet? Here's what this term. Does this help or not really? Doesn't matter. Okay. Okay, relative max. So if this is F prime, let's call that A, B, and C. Where is there a relative max on F? At B. Because F goes from increasing to decreasing. So if F goes from increasing to decreasing, what does F prime do? Positive to negative. So that's like when we made those intervals, right? If you had one interval that was positive and the next one was negative for your derivative, then you would go, okay, that's increasing to decreasing, that's a relative max. So this is F prime goes from positive to negative. It's going to equal 0 at that spot. And it would look, this is your x-axis, it goes something like that. It doesn't have to be that curve. It could be any curve. It could be a line. just has to go from above to below. Yeah. So the, right here, the y value of f prime would be 0, which represents the slope of f being 0. Start your question over. Because it's true that at a relative max, f prime equals 0. Like, yes. Because if it, basically you're crossing from above the axis to below. So when you do that, you're crossing through 0. And that's representing the slope of 0, like that peak turnaround on the original. You alright? Kenzie? Okay. Is this helpful? So far? Okay. I want to make it work. Alright, so relative min then. Negative, positive. It's going to equal 0 again. So where are relative mins on this f prime graph that I made here? A and C. So that's because we switched from a negative derivative to a positive derivative. And then what is the value of the derivative at that spot? 0. Which represents what's the slope of the original graph at that spot? 0, which is like the horizontal tangent line. So negative positive equals 0, and then it crosses, it can cross that, cross like that, whatever, as long as it's going from below to above. This is supposed to be above. Okay, let's say I gave you f prime, and it looks like that. Let's say A, B, C, D, E. I'm now looking at where's f concave up. Well, concavity comes from which level? Second, but I'm at the first. So how do I get to the second? I take the slope. If I want it to be concave up, I want the slope to be not increasing. Positive. It's different though. I want the slope to be positive. So where's the slope of this positive? Up until B, and then from D to infinity, right? So you want, if you're looking at the derivative, you want to know when f is concave up, you want f prime to be increasing, or has a positive slope. Those are the same thing. You said increasing. You said the slope would be increasing. That's different than the slope being positive. Slope positive just means it's going up. Slope increasing means it's curving. It's a different thing. Wait, say that again. Yes. Yes.
Why you right?
Increasing or positive slope. Those are the same thing. Like, for example, is this increasing? Yeah, it is increasing, right? Like this part right here. Y values are getting bigger. But is the slope increasing? It does not have an increasing slope. It's a decreasing slope. Right? Or if I flip it over, that graph increasing. Yes. Does it also have an increasing slope? Yes. This fella. Is that fella decreasing? Does it have a decreasing slope? Yeah, it's curving down, right? That fella. Increasing or decreasing? Decreasing, what about the slope? Increasing. It's curving up. Back up. That's a tricky thing, the difference between increasing and positive. Yeah, showed you here was supposed to be f prime, yes. Is that what you're asking? Is that the one you were asking about? What's up? Well, how can I help? Yeah, yeah. You want me to like remove the graph then? So then if I go back to the graph, like, where is this graph increasing? No. Increasing means getting bigger, right? Oh, okay, then look at positive. Increasing and positive slope are the same. So you can look at this and you can say to yourself, where's it increasing? Or you can say to yourself, where does this graph have a positive slope? The positive slope is here and here. But I'm not saying where's this graph positive. That's different. Like it has a positive slope here, but it's positive there. Is that helping or not? Literally, maybe. Say it again. Yeah. The values here are positive and decreasing. Okay. Like positive with a negative slope. Okay. So concave down is the opposite then, right? If you're looking at f prime, I'm asking you about concave down. You got to take a derivative, so you need a negative slope. Or you can think about that as decreasing. But so like kind of what Mackenzie was getting at is negative slope and negative values are different things, right? Like my bank account, like we're going to Disney, my bank account is decreasing rapidly. But it's still positive, thankfully. You know what I'm saying? Bitcoin right now is positive and freaking decreasing rapidly.
Really?
That's down, yeah. It's like 40 right now.
So once it goes below negative, that's
It can't be negative unless it's negative. Like, yeah. Like somehow I owed Bitcoin money. Flip what? It wouldn't. Okay. Like I just bought a Tesla and I'm going to Disney, right? My bank account is doing that. Still positive. Still got money. I can afford to eat. But it's decreasing and it's decreasing pretty rapidly at the moment.
Stop spending.
And then like I'll start to like recover, I'll stop spending money, and then I'll start saving. There's like a point of inflection where it switched from concave down to concave up. Yeah. Yeah, well you pay it like monthly, right?
Or unless you're paying cash.
Yeah, but that would be
Same
linear.
like gas.
Yeah, in fact, like dollars get into a whole different thing. Like it really, if I paid like all in cash, it would go like that. But then like, but you don't, you pay monthly, so I mean it's really more like this. Like it's not continuous and smooth, but I'm trying to get the general idea across.
And then you got to pay your taxes. Oh yeah.
All right, so point of inflection. Well, it's got f prime would have to change from one of these to the other, and it could be either way. So relative max and relative min, it's going to cross the axis. It's going to cross the axis, but it matters which direction. If f prime goes from above to below, f has a relative max. If f prime goes from below to above, f has a relative min. Well, concave up, there's not like point of inflection max and point of inflection min. It's the same either way. So if you cross the axis either way, so positive to negative, or negative to positive. No, sorry. Dang it. It's decreasing to increasing. Or increasing to decreasing. So it's peaks and valleys. So if I make another F prime graph real quick. Is that gonna do people have this written down?
Isn't it also slope equals?
Slope equals 0. The slope of F prime? Yes. You wanna write that too? So if this is your F prime graph, so if we think through that, F prime is increasing here, right? So what's the concavity? Conc up.
Right at the top.
And then right here, the slope is, now we're decreasing, yes? So now we're conc down. So didn't it switch from conc up to conc down right there? So that's the POI. So that's a peak, right? And then we went, okay, the slope here is negative, so second derivative is negative, so we're concave down. That is concave down, then concave up. So it would go like this. Conc up, conc down, conc up, and it changes at those spots. And it's conc up because F prime is increasing, conc down because F prime is decreasing, conc up because F prime is increasing. And it's at that is concave up. How we doing? Please ask questions if you got it. What's favorite movie? What's favorite movie?
Cars.
If you say 3, I'm gonna put you in prison. 3 is terrible.
No, three. Two is probably the farthest away from cars. After.
Are we okay at F prime? Alright. F double prime. If you see F double prime, what does it tell you about? Concavity. So it tells you whether the slope is curving upwards or curving downwards. It doesn't tell you anything about whether the slope itself is positive or negative. These two are like, you cannot get this information from this. At a relative max, this is not super helpful, but I think it's good to understand it. If this is your f of x, let's say that's f of x. So I'm flipping back to add. Concave down here, right? Isn't this a relative max? If you do have a relative max, what has to be true about the second derivative? Negative. What does the negative second derivative mean? Conc down. If you have a relative max, doesn't it have to be curving down for you to get that max? Because the slope's like curving, you get that peak, and then it keeps going down. So if you have a relative max, the second derivative is negative. That's not super helpful for any of these problems, really, I don't think. But it's good to understand like why that matches up. And then the opposite. So if you have a relative min, what has to be true about the concavity? It has to be concave up. So doesn't the second derivative have to be positive? Questions there? We're almost there. So F double prime. If that's your F double prime of x, and I ask you where the original graph is concave up, what does the graph I'm looking at tell me about? Concavity. original graph is concave up when f double prime of x is
I'm positive.
positive or negative. Here's your option. The graph of f is concave up when f double prime of x is positive, negative, increasing, or decreasing. Positive. Good. Right there, because you'd have f double prime of x is greater than 0, and that's like literally the definition of concave up. So this is positive. This is negative. So it's concave down. Second derivative would be below the axis. So you could say like above axis, below axis. And then we're almost there. So if the original graph is concave up when we're above the axis and concave down when we're below the axis, what happened? What's true at points of inflection? When it crosses the axis. When you go from above to below, or from below to above, you're going to go from concave up to concave down, or concave down to concave up. So you cross the axis in either direction. Either way. So, it might go like that, or it might go like that. So it's positive to negative, or negative to positive. And what's true about the value of the second derivative at that spot? If you're crossing the axis, what's the value? It's 0. So you can also put equals 0 there. So I was just going to say, you don't get to use this on the test, but if you find it helpful on the worksheet, hopefully just going through it was a helpful exercise. If not, hopefully working with it, what you're doing in the packet, referring to this. And there are some people that every year, when I give out the test that we're taking next week, you can't have this, but I can't stop you from getting your test, flipping over to the back and recreating this, and then using it. So if that works for you, great. I mean, it's just like writing down the unit circle or something, If you can create it from your brain, then you're not cheating. My hope is that it's a little bit more understandable than memorizable, but I get it. Do what you gotta do.
Both.
Yeah. Might be some of both. So I'll let you work on that, on the packet. Please let me know if I can answer some questions as you're going. I didn't even take that much time. I find you worthwhile.